Hello and good morning, good afternoon to everyone. So today I'm going to solve a Web3 blockchain challenge from Tryhackme. I have deployed my machine on this IP address, and the contract is about a weakness in the Cypher smart contract, and we have to train on the Ethereum in its treasury. So let's start. So here we have our smart contract. Let me zoom in so you can see much more better. So our contract called challenge. We have two state variable here, addresses private owner and address private init owner. And we have also constructor. If you don't know what is a constructor, constructor is a special function that runs only once when the contract is deployed. And by payable here means that both two addresses can receive Ethereum. So we have the first function here, change ownership, and it's external. By external mean this function is callable only from outside the contract. And we have here also another function, withdraw external. And we have here another function called get balance, external, also called from outside the contract. But there is a difference here between all these two functions and the rest of the functions. These functions, they change the state in the blockchain. On the other hand, these functions are just view functions. They don't perform any changes to the blockchain. They just view functions. They do not consume any gas or any gas fees. So let's go through them one by one. So this withdraw function, which is external function, require a message sender equal to owner. If not, you cannot withdraw the fund, all the fund of this contract. But if you are the owner, you will be able to withdraw all the fund. Here we have function get balance, return the contract balance, and here another function that can get owner balance. It returns the owner who deployed the contract wallet balance. Here is a solve it, another function to see if the contract the challenge is solved. And two other function, get address. We can see the return message sender, who is the one who sent who called this function. And here we get the owner. It's a function that shows us the wallet of the owner. So what I prefer to do most of the times, I'm going to take all of this contract, smart contract. I'm going to Solidity, and I have already pasted the contract. Okay. This is our contract in Solidity. I do this most of the time so I can get the contract is compiled and we can deploy it, but I'm not going to deploy it here. I do this so I can get the ABI of the contract, and now you can see, after a while, you can see why. Let's copy this ABI and let's get back to our contract. Okay. So let's start. I'm going to solve this through using Python Web3 library, which I prefer doing most of the times. So let me close this window and let's run a new window, and let's create a directory called challenge Web3, and let's see the challenge Web3. Let's create a Python virtual environment, Python 3 VMB, and let's call it hacking contract. You can call it whatever you want. And now let's do ls cd hacking, and let's now source bin, and I'm going to do activate. Now we are in our virtual environment. First thing first, I'm going to install Web3 library. Let's give it some time. So I have installed our Web3 library. Let's create this. Let's create a .py. Would like to open it this way, hacking, so py. So let me zoom in and let's start creating our code to hack the smart contract. First thing, we have to import the Web3 library. So we are going to from Web3. So I'm going to import, it's like this, it's from Web3 import Web3, and we are going also to import JSON, and you are going to see why I'm importing JSON. So let's create our RPC, which is Web3 open parentheses and Web3 HTTP provider, and we have to provide our node that we are going to connect through. So in our case, I'm going to check what is the node that we have to connect. This is the node F, which called get. I have to edit because I'm connecting through Tryhackme VPN. So what I'm going to do, I'm going to take this IP address here, copy. I'm going to do sudo nano etc hosts. Oh, sorry, let's open another window, zoom in, sudo nano etc hosts. I'm going to add our new IP. Okay, everything now must work fine. Let's put here HTTP get, and I believe it's 8584. Okay. Now we can do one more thing I like to do when I connect to the mainnet like Ethereum or Binance. I do if W3, which is our RPC node, is connected, friend connected, else friend not connected to the blockchain, not connected. Okay. And now remember the API that we copied. So I'm going to our project here. I'm going to ls hacking. I'm going to create a new, let's say nano. Let's call it the contract.json. Going back to this IDE, copy the API, and this is our API that we're going to use to connect to our smart contract. Let's save it, and let's get back to our code. So I'm gonna do with open, and we're gonna say contract.json as f. And I'm gonna do API equal to json.load F. Now we have loaded our API that we are going to use to connect the functions on the smart contract. Now let's initiate a variable for our contract. Let's say contract address. I'm gonna do Web3 to check some address. This is going to be our contract address that we are going to put later. And we are also we need a wallet. My wallet address, our wallet. I'm gonna put our wallet in here. And we need also the private key. This one we're gonna use to sign and send the transaction. Let's go to our contract and let's copy everything. So this is the player wallet. Let's take the contract address, copy. Let's put it in here. Paste. Let's also take our player wallet, which is going to be here. And let's also take our private key, which is going to be now. What we have to do is we have to create contract instance so we can be able to connect to the smart contract to Web3 RPC node ETH contract that's taken two variables. First one is address, which is contract address. Second is the API, which equal to API, this one. Okay, now we have created our contract instance so we can connect to the smart contract on the blockchain. We are also going to create a nonce, which is W3 w3.eth get transaction count, and we're gonna give it my address, my wallet, sorry, wallet. If you don't know what is a nonce is the number that represents how many transactions an address has sent. We need this so we can sign and send our transactions. So now let's get back to our contract and see which functions we are going to call. The contract is here initiated and we have to change the owner so we can train the funds on the contract. Let's check who is the current contract owner. So we're going to call this function, which is external view and returns an address. Okay, how we're going to do that? We're going to say owner, and we're going to say contract instance dot functions dot get owner. Let me check again the name of the function, get owner. We're gonna call this function. Now we're going to print the owner. let's also print my wallet so we can make a difference. We can see the difference. Okay, let's run this code. Ls, what's the name? It's Python 3 hacking.py, and we have a unknown format attempted. Analyze. We have a problem here. Unknown format. Web3 checksum. Oh, okay. No, Web3 to checksum address. Let's do known format F2 to Web3 to checksum address. Okay, clear. 3 to checksum address. Oh, guys, I fixed the error. It was like I copied the not the full address. So what I had to do, I just went here, view page source, and copied the full address of the contract. Now let's run it. Let's see. Python hacking.py. So here, this is our address. This is my wallet address, and this is the owner address of the contract. So what we have to do now, we have to become the owner of this contract so we can withdraw funds. Let's clear and let's proceed. So let's delete these two functions that we don't need. Let's go and check and let's also do this, and let's go back and check our smart contract. So we need to change the owner external function. So owner become the message sender, the one who calls this function. So let's do that. What we are going to do, we are going to create a transaction. Let's call it TX. Okay, because we are going to create a transaction. As I said earlier, this function is going to perform change to the blockchain, which means we have to create a transaction, we have to sign it and send it. So let's do that, and we're gonna see together who's becoming the. But before doing that, let's get back to this one. Let's run it again. Right, and let's do this. Owner.txt, so we can see the difference later. Cut owner.txt, and we have, this is the owner, and this is our address. So with this address, we have to become the owner of the contract. So let's proceed. Let me delete this, and let's create a transaction. TX contract instance dot functions. Our functions called is change ownership, and if you want to know also, let's do get contract.json grep ownership ls contract.json grep ownership. It's change ownership. Okay, let's do this. Open contract.json. So let me zoom in, and we have this function here. That's why we copy pasted the API. We need it so we can interact with the smart contract. So change ownership, we're going to call this function. It does not take any input, does not show any output. It's State mutability non-payable, which means it requires gas fees to be executed. So let's get back here. So let's call this function, which is called change ownership. And as I said, it does not take any contract. Sorry for this copy hacking. Does not take any input, as we can see here from the contract also. It's empty. And let's build a transaction. Okay, let's do it. So first thing, we start by the chain ID, which is in our case 37. Don't really remember what is our chain ID. 31337. For Binance is like 56, and for Ethereum is 1, I believe, 7. What do we need? We need gas because it's non-payable, and we need gas. So let's put 75,000. It's enough to change such a function state. And we also must provide gas price. Let's say 2 way, and let's give it 0.01 like way and G way. Okay, and also we need the nonce to track our wallet transactions. Okay, a nonce, which is this one. Okay, now what we have to do, we create our transaction. We need to sign TX. We sign our transaction. W3 is dot account sign transaction, and we need to sign it with what? With sign our transaction X, and we have to sign it with our private key. So let's do it. Let's run this function, this code, and we see if we are going to become the new contract owner. Connected, and we have print my wallet. Okay, this is the function print my wallet. Okay, if you want to see that, we can do what we did, owner as earlier. Let's do Control Shift. Let's delete it. We don't need it anymore. We just do contract instance functions get ownership. We call, let's print owner. Let's run this to see the new ownership hacking. Get ownership function, it does not exist. I have made a mistake. Ownership. Let's see the function is get owner. Sorry, get owner. Let's go here again, clear Python hacking. Yes. So I think let's do cat ls cat owner .txt. We did not do, it's not this function, so got owner, it's return owner. So we did not change, and we did not perform any change in the smart contract. Okay, let me see why. Normally we have initiated this transaction, it must be the owner, because of the message sender. Okay, cat owner. See, it did not do anything. Oh my god, sorry. What I did here, look, I signed the transaction here with the private key, but I did not send it to the contract. That's why nothing happened. So let's send this transaction. Let's call tx hash weth w3.eth send row transaction. Let's do the sign tx dot row transaction. Now it must, if we want, let's call the other function, which is message sender. This one don't need it. Get owner ownership. It does not hold ownership. It's not ownership. It's get owner. It's get owner being as owner. Let's do contract instance functions get owner, and let's make call. Okay, let's see what's going to happen. Let's come here. Let's clear this and let's Python hacking. Let's go connected owner, and let's get owner owner.txt, and we are going to see now that we are becoming the owner of the smart contract. This is our address. This is our address, as you can see here, up here. And now we are the owner of the contract. Now we can drain all the funds and get the flag from the contract. So let's do it. So to drain the funds, what we should do, just the same thing. It's a function here. It's a function here. It's a withdraw function, and it requires the message sender to be the owner, which already did that. So we can withdraw all the funds and get our flag. Challenge is not completed yet. So let's do this. So let's keep this one because it's almost the same thing. Let's do withdraw this time. This time it's withdraw. It does not take any input, and automatically it's going to send this transaction to the owner. It's going to pass this require statement, this checking statement is going to pass because we are already the owner, and now it's going to send us the money of this balance of this contract. Let's do this. So chain ID same, gas price and nonce. Let's do it. And guys, as you can see here, this is our wallet balance. You're going to see that it's going to change because we are going to withdraw all the contract balance. I did not get balance. We didn't do this function, but if we want to, we can do it now. It's the same as this one. Let's comment this, or let's delete it. Or comment it. 1 second. Okay, let's delete this. I'm gonna get to it later. And let's call the balance. I think it's the name of the function. It's get balance, as we can see, balance of the contract. Let's say here balance contract balance Let's print contract balance. Yeah, let's save and let's run. We have 18.0, which means this contract contains 2 Ethereum. Okay, let's get back to our functions. This one, let's delete this owner, we don't need anymore, and let's create a new transaction so we can withdraw. So withdraw here, as I said earlier, it does not take any input. Perform a check to see if the message sender is the owner. If not, it will drop here the function. Else, if it passed the check, all the funds, this address, this balance will be transferred to the owner. So this is our function. We don't need anything, just we need to indicate the chain ID, the gas that you are willing to spend on this transaction, the gas price, and the nonce. We have to sign the transaction with our private key, and we have to send it, and we're going to see that this is going to be like 3.99999, and this way our challenge is solved. So let's do this. Okay. It passed through. It's always printing because here we did print our wallet. It's always printing, and if we go and check our contract, we're gonna see our balance is becoming 200. We still not 2 ETH, it was 200 ETH. This is our wallet balance, and we have now 200 ETH. If we go and click on get the flag, the room is solved. So guys, thank you for watching. This is our first Web3 challenge. I will be putting more and more challenges online with other tips and courses maybe in the future. Please like my video, and if you have any questions, feel free to comment. Thank you so much for watching.